In this video, we're going to start looking at Chapter 4. Your book has a different name for it, but I like to call this chapter Common Statistical Measures. The reason for this is because essentially all we're learning in this chapter are some of the foundational statistics. Things that are going to crop up time and time again, both throughout the rest of the semester and also when you go into, when you go into any higher level statistics as well. All right. That being said, we're going to be doing math for the first time in this chapter as well. Well, we've done a little bit of math, but not quite the same. So before we actually start looking at these statistical measures, there are a couple of notation things that we want to look at, so we're all on the same page so that we can all know how to read these formulas. This is important because you'll soon be seeing these formulas, and especially the first time you see them, they can look a little daunting. Of course, once you get used to working with them, it becomes trivial, but especially at first, and I don't necessarily expect you guys to memorize all of these formulas, right? You will be given a formula sheet on the exam. I would rather you know how to read the formulas, right? So as long as you can read the formulas, you don't necessarily have to know how to, as long as you know which formula is going where, you have the numbers, you can plug those in, and you can get by doing that. All right, so without further ado, let's go ahead and just clear our screen right now, and then just start looking at some of these things. All right, so one of the first things I want to point out, and this is something that we're going to see in just a little while, is that there are differences in how we notate parameters and statistics. All right, so parameters, so if we remember, parameters are the things that the facts or figures about a population, right? So this parameter is the whole thing, right? We use all the data that we could to calculate that parameter. Right, so parameters are going to be notated using Greek letters, right, or Greek characters, right? So we're going to see that, but if you see a Greek character that's telling you that is the parameter, all right? So again, helpful to be able to identify if you've just got the formula to be able to identify those. Also, to later on, you're going to need to be making decisions based on whether you have the parameter or the statistic. So if you know parameters are represented with Greek letters, and you see something that's a Greek letter, you know it's a parameter, and that's the direction you want to go. All right. Opposed to that, we have statistics. All right, and statistics are notated using the Latin alphabet, right? I think maybe it's also the Cyrillic no, that's not right. Anyways, it's our alphabet, the one we use, A, B, C, D, so on and so forth. I think that's the Latin alphabet. Regardless, that's what we use, all right? And again, we're going to see that difference here in just a moment. All right. The next thing that we're going to talk about is the difference between X and X. And so really what I mean is the difference between capital X and the lowercase x. All right, so the capital X, when we're looking at this, a capital X, and I'll be honest, this one we're not going to see crop up until after our first test, but it represents a variable, right? So we know that characteristic of interest, whatever it is that we are looking at, that is our variable, and capital X is the variable as a whole, so kind of the title of the variable, right? X is not as a whole. Often you'll see it notated as such, xi, x with a subscript I. This is the ith observation of the variable, right? Or capital X. Right, so that I is just a placeholder for a number, right? So the first, second, third, fourth, fifth observation of our variable, so on and so forth. A lot of times you're going to see this xi along with another symbol. Right? It's going to look something like this. Right, so this is the weird little thing, xi. Well, what that weird little thing is the summation symbol. And so this is an operator. It's telling you to do something like a multiplication symbol, minus sign, plus sign, so on and so forth. Right, so what the summation symbol is telling you to do, we might be able to know just from the word summation. You're going to just add up everything that is in front of that symbol. Right? So that's why it's called the summation. You take the sum, you add all of those together. Now let's look a little bit more at, ooh, that was a bad one, how these work. All right, so our summation symbol, we might have something out here. Now, actually, before I do that, so the summation symbol, I don't know, I did that, it's not really additive, but that summation symbol, it usually doesn't actually look like that, at least not properly. Most of the time what it's going to look like, and we're not going to do this too much, we're just going to, it's kind of assumed, because this is how it is almost every time, and you really might only change it if it's different, might actually specify it only if it's different, right? But this is what they will look like. So down here at the bottom of the symbol we see I equals 1, up at the top we have n. So what this is telling us to do, if we're reading the formula mathematically, is saying take the sum, so actually we'll just walk through this, right? So take the sum of xi from where I equals 1 to I equals n. So we want to add up all of our xi's, all of our observations, from the first one, I equals 1, to the last one, right? N, that's our sample size, it's the total number. Right, so what we're doing is x1 plus x2 plus on and on until we add on that last one, xn. Alright, so that is what our summation symbol is telling us. One thing to note is that the laws of, or the order of operations rather, still apply. So if you've got the sum of xi times yi, you're not just going to add up all of your xi's and then multiply it by a single yi. One, you can't really do that because there's multiple yi's, right? This is telling you that you need to multiply, oop, that's not a y, the ones that go together. Just keep messing that up. So x1 times y1 plus x2 times y2, on and on and on. Right? We're not going to see that for a little bit, but that is something that we're going to need to keep in mind. All right, so that's it as far as our notation goes. Again, notation is going to be pretty important. Knowing the symbols, what symbol represents a specific statistical measure, so on and so forth. How changes in those symbols are going to change formulas, so on and so forth. All right, it's going to be very important. Right, if we know what these symbols are, right, it's going to make it much easier if we kind of lose our way to get back on track, not trap. But we'll actually go ahead and end this video so they don't get too long, but that's just a quick overview on some notation things that we want to keep in mind. I'm sure there are things that I've forgotten that are going to be important that we're going to need to update. We'll address those as we go along. That's it for this video. In the next one, we're going to start looking at the first of our types of measures, measures of central location.